Hello friends, a very warm welcome to all the viewers of Wisdom Jobs. In this video, I'm going to do some more problems based on radioactivity and specifically more, I am going to work out some problems based on alpha particles, beta particles and other radiations. Now, before going to these problems, I'll request you all to please do subscribe to our channel wisdomjobs.com because we are going to upload many videos every day which are useful to you and in the way of competitive examinations or your board examinations. So please do subscribe and like and share our videos to your friends and other groups also, so that they also will be benefited by these videos. So with this note, let me start the topic. An atom has atomic mass of 232 and an atomic number of 90. So he did not name or mention its name, so let us take it as some x. Of course it is thorium because the atomic number is given to be 90. During the course of disintegration, it emits 2 beta particles and few alpha particles. That means he is asking you to determine the number of alpha particles indirectly, right? So few alpha particles. The resultant atom has an atomic mass of 212 and a mass number of 82. So how many alpha particles are emitted during this process? So always what I just tell you is write the disintegration equation for such problems, then you are going to get the solution very easily. Now let us write the disintegration equation. So which atom is getting disintegrated here? An atom whose atomic number is 90 and mass number is 232, right? So let me name that element as, of course we know that, so thorium. So let me write it as thorium. So TH 90 232 is the representation of thorium for you. So TH 90 232 disintegrates into during the course of disintegration it emits 2 beta particles and few alpha particles. So let me take the number of alpha particles as x. Okay, number of alpha particles. Okay, so the resultant atom has an atomic mass of 212 and atomic number 82. So which is that element which has got an atomic number 82? It is lead. So it is Pb. So Pb 82, the mass number is given to be 82 and atomic mass is given to be 212. So 212 plus, yeah, we don't know how many alpha particles are emanated or emitted, right? So I am assuming that the number of alpha particles emitted are some x. So x into it is, what is the representation of an alpha particle? It is helium 2-4 plus beta particles are given. So it emits 2 beta particles. So the number of beta particles are given to be 2. So 2 into, what is the representation of beta actually? It is E minus 1 0, right? So now this is the disintegration equation. So once you form the disintegration equation, it's very easy and every Tom, Dick and Harry can easily solve this particular equation. So what is the next step I told after writing the disintegration equation? Compare the mass numbers and atomic numbers. So as simple as that. So if let us compare the mass numbers first. So if I compare the mass numbers, what do I get? 232 is equals to 212 plus x into 4x. So obviously what is it now? 4x is equals to 20, or x would be equals to how much? 5. So x is simply 5. So how many number of alpha particles are emanated? It is 5. Okay. So of course the other equation also will be, so we will be tallying actually. So 90 is equals to 82 plus 5 to is 10, 92 minus 2. Okay. So if you write this, if you take the comparison of atomic numbers also, the equation will be solved. How? Let us compare the atomic numbers. So if I compare the atomic numbers, 90 is equals to 82 plus 2 into x, okay, that is 2x, minus 2, or 90 is equals to 82 minus 2 will give you 80 plus 2x, right? So from this, what is x value? X value would be 90 minus 80 by 2, which give you as usual 5. So if you compare the mass numbers also, you'll be getting 5, and if you compare the atomic numbers also, you're going to get 5. So if you are confused in this particular problem, check whether you are getting the same x value in both the atomic numbers and the mass numbers. So if you are going to get the same atomic number, same value of x in both the cases, your problem is, or your solution is perfectly correct. Okay, now let us move to the next question. How many moles of helium are produced when 1 mole of U-238-92 disintegrates into lead? It's very easy now. Let us write the disintegration equation. So, which is disintegrating actually? Uranium. So, U, and I told you, 238-92 means it is U92 238 is equals to PB. What is it actually? 208, I mean 206 is here, and 82 plus how many we should determine the number of moles of helium. What is helium actually? It is nothing but an alpha particle, is it not? So indirectly he is asking you how many alpha particles are produced, understand? So plus, now let me name, I mean helium is what? The representation is 2 4. So let me take that number of helium atoms as X. Helium 2 4, right? So now same mole procedure, compare the mass numbers and atomic numbers, and you are going to get the value of X. Okay, so now if you observe, let us compare the mass numbers, or let us compare the atomic numbers for that matter. So if I compare the atomic numbers, 92 is equals to 82 plus 2x. From this, what is X here? X is 92 minus 82 by 2, which give you 5. So how many moles of helium are formed? 5 moles of helium are formed when the uranium 238-92 disintegrates into lead 82-206. Understand? Now let us work out one more problem, which is the last problem for this particular topic. How many alpha particles and beta particles are emitted when thorium 234-90 changes to polonium 84-218? Okay, now simple. I'll go for this same disintegration equation, and let me take X be the number of alpha particles, okay, and Y be the number of beta particles. Okay, so X is number of alpha particles and Y is number of beta particles. So if I am taking like in such a way, then let us write the disintegration equation. So if I write the disintegration equation, what am I going to get? Thorium TH 90 234 gives rise to, now what is it? What is the final product? It is polonium 84 218 plus X into He24, Y X into He24, it is the number of alpha particles emanated or emitted, plus Y into E minus 1 0. Okay, now let us compare the mass numbers and atomic numbers on both sides. So if I compare the mass number initially, let me say if I compare the atomic numbers, why I am going for initially mass numbers comparison? Because here it is 0. So the mass number of this electron is 0. I mean the beta particle, right? So for that reason, it is easy to always compare the mass numbers initially to get the number of alpha particles. Once you get the alpha particle number, then substitute, then compare the atomic numbers to get the number of beta particles. That's generally the procedure. Okay, so now let us compare. So 234 is equals to 218 plus 4x. That's it, plus 4x, right? So from this, what is 4x? 4x is equals to 234 minus 218. So how much is 234 minus 218? It is exactly 16. Or from this, x would be 4. So how many number of alpha particles are emitted in this disintegration process? 4 alpha particles are emitted, right? Now let us compare the atomic numbers. So if I compare the atomic numbers, what do I get? 90 is equals to 84 plus 2x. X is let us write x only initially, and later we substitute x with 4. So plus 2x minus y. Okay, now we know x value. So from this, what can I do further? 90 minus 84 is how much? 6. So 6 is equals to 2 into what is x actually? 4 minus y. Now from this, 6 is equals to 8 minus y, or y is equals to 8 minus 6, and that is how much? 2, right? So number of alpha particles is 4 and number of beta particles is Okay, so this is the final answer. This is your final answer, right? So obviously please try to do so many problems based on this concept, because there is one compulsory bit in either IIT-JEE or NEET examination on this particular topic of radioactivity. Of course, in the next video we are going to I'm going to explain you about the half-life period and the equation. So the logarithmic equation, how to calculate the half-life period and generally the period of a particular radioactive element. Okay, so with this note I'm completing this video. I'm ending this video. So if you have got any queries in this particular topic, please do express your doubts or queries in the form of comments, and whenever we find time we are going to answer your queries. So I think you have enjoyed this session, so please do subscribe, like and share these videos among your friends and other groups. So thank you for watching. Have a nice time.